teacher, in terms of the u and the du. Well, e to the x minus e to the negative x, that's what I'm calling du dx. In the denominator, I've got 2 square roots of u, and I've got the dx. I was able to replace pretty much everything in my integrand so that now it's in terms of u, du over dx times the dx. I hope everybody's okay. The dx's are going to cancel. If they don't, you're doomed. Like, it would be the absolute wrong thing. And so then now I just have to integrate, well, what's left, du over 2 square roots of u. Does anybody recognize that form?
Yes.
You recognize that form? What's the antiderivative going to be?
Square root. Yeah, square root of u.
This should just be the, right, what function would I take the derivative of to get here? Square root of u, because the square root of x is 1 over 2 square roots of x. If it's helpful, maybe what you want to do is just use a little bit of algebra and call this 1 over 2 square roots of u, not dw, du. This guy here, you should know. You get the square root of u plus Charlie. Life is good. Make sure you go back. If you started life in terms of x, you're going to end your life in terms of x. And that's integration by substitution.
Whoa.
Everybody mostly okay?
Yeah.
Like, usually for the BC students, integration by substitution goes pretty well. But here's the thing. Lewis, you might be like, great, so integration by substitution, that's it. That takes care of all the problems we're ever going to see. No. No, son. This takes care of a nice wide portion of integration problems, and there's a ton that we can't do using integration by substitution. But that's what the next, semester's all about. All right, so with that said, see what you guys can do with problems 4 and 5 in the bottom here. 4 and 5 on the bottom of page 23. Wait, where's the other one? You guys can't keep the black market value on these is way high. Caroline could call us if there's something.
I didn't finish them because I didn't reach that from the list.
Okay, well, I'll just get that real quick.
You should take a look at 32.
I should take a look at 32.
Definitely.
Okay, I'll do it. All right, this is all about multiple choice and free response from all the friends. Oh, Bill. Sorry.
Oh, there's a new thought for me.
Possibly. Possibly.
That's it?
So you want to be careful, like identifying the baby, not too bad, but you got to make sure you see derivative of the baby as well. So, Myra, what are your thoughts on number 4? If you're going to approach this one using integration by substitution, what's the baby?
4 minus 2t to the power 1.
Okay, u is going to be 4 minus 2t to the 4th. And then the derivative?
T
You got to be careful. What's the derivative of this guy here?
8t to the power 2.
Ooh, no, not 8.
The other way.
Not 8.
Negative?
Negative 8? Negative 8? Okay, now what you write on the left side is really important. Please don't write du dx. Du dt. You're taking the derivative of u. U is the function, but the variable is t. Alright, so if u is the baby, do we actually have the derivative of the baby showing up here in the integrand? Not quite, because I've got t cubed and the derivative is supposed to be negative 8t cubed. Here's the thing, with integration by substitution, any legal algebra is okay. So for example, a legal algebra thing that you might decide to do, what about if you multiply, what if you get a new marker? What if you multiply everything by negative 1/8? Is that legal? Sure, as long as you're doing it to both sides. And is that better? Sure, because now you're going to tell me that negative 1/8 of du dt is equal to t cubed, and I do have t cubed in the integrand, so things start to come together. When I do the rewrite, instead of t cubed, I'm going to call this negative 1/8 du dt. In the bottom, it used to be 4 minus 2t to the 4th to the 11th power. That's now u to the 11th. And I've still got the dt. Hopefully we're okay, those are going to cancel out. But I'm still stuck having to integrate negative 1/8 u to the 11th du. And that may not be something that most of you all just look at and know what the answer is. I don't know if you can turn that off. So what else? What other thoughts are out there? What other legal things could you do that might get you to something you can integrate? Not legal calculus stuff that you could do. So say negative 1/8 divided by u to the 11th du shows up nowhere on a integration foldable. But get clever. What are some legal algebra things or legal algebra calculus things that you might be able to do to get this to look a little friendlier? Okay. Is it okay to rewrite that u to the 11th in the denominator as u to the negative 11th? Sure. The other thing I'm thinking about is that negative 1/8. Right, that negative 1/8, it's just a constant that I'm multiplying by, so what if I pull that out? To get to negative 1/8, and Polymode's recommendation was to rewrite u to the 11th as u to the negative 11 du. Why is that better? Power rule. You're at the power rule. You've got something raised to a power, and the power rule says add 1 to the power, and then divide by the new power. So you're going to have negative 1/8 times u to the negative 10 over negative 10 plus Charlie, negative 1/8, this negative 10 is in the denominator, I could pull that out and really maybe make this 1/80. U to the negative 10 plus Charlie. U started off its life as, was it 4 minus 2t to the 4th? And maybe what I would do is write this as 1/80, 4 minus 2t to the 4th over 10 plus Charlie. That's not something that I think anyone in the room, myself included, would just be able to do by looking at it. But hopefully integration by substitution makes things a little bit more obvious. What questions do you guys have about that one? Okay. See what you can do at number 5. Oh, okay. Okay, so but u is going to be something involving theta, and it has to be du d theta. for number 5, what are your thoughts for the baby?
For the baby?
Yeah.
Theta to the third power plus pi.
Okay, theta cubed plus pi. And what I'm going to say right now is, maybe it's the baby. I'm going to know for sure it's the baby after this next step, take the derivative. And if I take the derivative using the right variables, this is going to be du d theta equals 3 theta squared. And the question I want to ask is, do I see 3 theta squared in the integrand, or can I get the integrand to look like this?
We get the integrand.
Sure. Lewis, what would you do?
Divide by 3, both.
You could divide both sides by 3. Somebody else might say, oh, what I want to do is I'm going to multiply by 1/3. Same thing. Right? So what you're going to get is that 1/3 of du d theta is equal to theta squared. So in the rewrite, theta squared is now 1/3 du d theta. Secant squared of all that stuff is now just secant squared of u, and then d theta. The d thetas cancel out, and that is a must. You've got to be able to get your integrand to be just all in terms of one variable. So now I've got 1/3 secant squared of u du. I may have jumped a little fast there. This du that was in the front, I just moved over here to the end where it's supposed to be. What do I know of that has secant squared as its derivative? Should be tangent. So this has to then be 1/3 tangent of u plus Charlie, and then go back, make sure that you rewrite the tangent of theta cubed plus pi plus c. For the most part, everybody okay? You just need some practice. If anybody's really struggling with this multiplying by the constant, let me know. I've got another strategy I could show you. All right, see what you can do with the next one. I'm really interested in 6 and 7. Is anybody interested in seeing a different way to do substitution? You are? Okay. For everybody else, just keep going. So here's a slightly different way. Okay. So for number 6, good guess as to what the baby's going to be? X squared plus 9. You're going to take the derivative, and the derivative is going to be 2x. Okay. Here's the different idea. What you're going to do is you're going to solve for dx. You're going to come back over here and you're going to rewrite the derivative of the baby in terms of as dx. So I want to get to dx equals something. The algebra that you would need, you could maybe multiply both sides by dx, which is still legal. And so you're going to say that du equals 2x dx. But that's not solved for dx yet. You're going to divide both sides by 2x. And if you do that, you're going to say, oh, well, du divided by 2x is equal to what dx is. So in the rewrite process, you're going to say, okay, ignore that 5x for right now. I'm not really sure what to do with it. X squared plus 9 is u. Dx is really du over 2x. And rather than having to think about, I guess it didn't show up over here, oh, I've got to multiply by -1/8, or I've got to multiply by 1/3, you just let the algebra take over here. I've got 5x over u times du over 2x. The x's are going to cancel each other out. The 5 and the 2, those are just constants that I can factor out. And then you've got the integral of 1 over u du, which is hopefully an obvious one. This is going to be natural log of the absolute value of u plus Charlie. So it's 5/2 natural log absolute value x squared plus 9 plus c. It's a nice little trick to have in the toolbox where you're like, let me identify the baby, let me take the derivative of the baby, and rather than having to, like, what do I multiply by, just solve for dx using legal algebra. And then do the plug-in. And the constant just sort of magically shows up in this process rather than you're having to think, oh, I'm going to multiply both sides by 5/2 or 2.5 or something like that. How many guys were able to get there without doing the solve for dx? Good luck with number 7. Oh yeah. Sexy voice has been replaced by pirate. The solve for dx, right? Not 2 theta though. 2 square roots of theta? So it looks like most folks have gone with u is going to be square root of theta? Yeah.
I think it is 2 theta.
You think it is 2 theta?
Because if you, well, the 2's will cancel out, and it could be theta, like you could put it at the top and make it theta to the negative 1/2, and so.
Oh, now I'm in your head. Now I know what you're doing. Okay. So u is going to be square root of theta. U d theta 1 over 2 square roots of theta? Everybody okay? Okay. In the rewrite, though, you got to be careful, because some folks are going to say, oh, then this means that what I'm trying to integrate is the sine of u in the denominator, square root of theta is equal to u. Then they're like, but what the heck is the d theta? Like, what is it that I'm doing there? And so you're like, but I haven't used this part. Sine of u du d theta is 1 over 2 square roots of theta. I've got a square root of theta in the denominator. I've got a d theta over here. Not too bad. If you try this new strategy of just solve for d theta, well, how I'm going to solve for d theta, I could cross multiply to say du times 2 square roots of theta is equal to d theta. Right? This guy times this guy equals that guy times that. Sine of u over the square root of theta, replace d theta with du over 2 times the square root of theta. Square root of theta down here, square root of theta up there, are going to cancel each other out. And you're going to have that 2 that's left, that's a constant, I can pull it out. So I've got 2 integral sine of u du, what is that, -2 cosine of u plus Charlie, and when you go back and substitute, it'll be -2 cosine squared of theta plus Charlie. We're going to spend all day on Monday and all day on Tuesday with integration by substitution, just continuing to get really good at this. The homework this weekend doesn't have anything to do with integration by substitution. The homework is assignment 93, which is in the problem set packet. It's just practice with integration. Basic integration, some definite integrals, should be very comfortable. Just finish clearing the cobwebs off. I'll see you guys later. 93.